Okay, and for 4 through 6, we'll be looking for horizontal shifts in a table of data. On your sheet, you should have two tables, Table A and Table B. Now, both those tables have an X row, which is all the inputs, and an F of X row, which is all the corresponding outputs. And Table B has its X inputs in its first row, and its G of X outputs in the second row, which would be the outputs for each corresponding X input. For number 4, we're to compare inputs from corresponding outputs for the F and G functions, and we're supposed to note what we notice. Now, the first thing I notice is that if you look straight up and down on your each columns, all of our outputs are the exact same. Like we've got 9, 4, 1, 0, 1, 4, 9, 16, 25. But then if we actually look at our X rows for both, those X rows are different. So we actually, for A, we put in a different X, and we get out a different, and we get the same Y out. The one thing we can look at is that every X value that we put in column, or in table A, is actually 2 less than every input that we put in table B to get the same output. Now, if we go to number 5 using function notations, such as f of x equals, we can write a formula for the function in table A. If we kind of look at what we've got here, when we start at 0, we kind of go out to 1, and we get 1, we go to 2, and we get 4, 3 we get 9, 4 we get 16, 5 we get 25, and when we go in the negative direction, negative 1 as an input gives us 1, negative 2 gives us 4, and negative 3 gives us 9. This tells me that our formula for f of x should be x squared. And to test that, we can put in our values. So if we put in negative 3 squared should be 9. Negative 2 is 4 when it's squared. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. So it looks like that works. Now when we go on to number 6, we're supposed to use function notation such as g of x equals, and we're supposed to write a formula for the function in table B. Now unfortunately table B isn't as nice with negative 1, 9, 0, 4, 1, 1, 2, 0, and so forth, but we can use the relationship that we found out in question 4 to kind of help us out. In question 4 we had noticed that all of the table A values were 2 less than the table B values. So we can kind of use that and look at, well, okay, if we wanted to get the same outputs from those, if I wanted to somehow get a negative 3, for example, with my table B, if I needed to get negative 3, I could take 2 from my negative 1, which would give me negative 3, and then when I squared that, I'd get 9. So off the bat, I would look at, okay, well, x minus 2, and if I square that, I should get my value. Before I write that in, though, I'm going to test it. If I were to minus 2 from 0, I would get negative 2, and if I squared that, I would get 4. So that works. If I had 1, if I minused my 2, I would get negative 1, and if I squared that, I'd get 1. If I had 2 and I minus 2, I'd get 0, and if I squared that, I'd get 0. If I had 3 minus 2, I would get 1, and if I squared that, I'd get 1. If I had 4 minus 2, I would get 2. If I squared that, I'd get 4. And if I had 5 minus 2, I'd get 3. And if I squared that, I'd get 9. And if I had 6 and I minus 2, I'd get 4. Squaring that gives me 16. And if I have 7 minus 2, I get 5. And squaring that gives me 25. So it looks like x minus 2 quantity squared would be my correct formula for g of x. Now we're to write a formula that relates f of x and g of x in a single equation. So this is similar to question 3 with the graphs. Again, to start out, I'll look at both of my equations. So I have f of x equals x squared, and g of x equals x minus 2 squared. So again, doing similar that we did in number 3, if we kind of just look at the inputs, what happens to them, we've got an x, we've got x, the input is squared, and on g of x, the input is minus 2 then squared. But if we just look at the equations, again, both of them have a component being squared. So if we were to look at what would happen if we were to put x minus 2 in for x, or for f of x in for x, we would get x minus 2 squared, which would be g of x. So we know that g of x equals f of x minus 2. Because again, if we put in x minus 2, we would get out x minus 2 squared. So g of x equals f of x minus 2. So whether we have a graph or a table, looks like we'll be able to handle those very nicely. Hopefully this lesson's been fun for you. If you need any help, again, there's the online lessons. There's also more videos. And as always, fun in class. Have a nice day.